Okay, first we look at this inverting amplifier using op-amp. And now inverting op-amp is an operational amplifier circuit that produces an output signal of 180 degree out of phase with the input signal. It's a fundamental building block in analog electronics that uses negative feedback to precisely control the circuit's gain. Okay, this is normal circuits of an inverting amplifier. We will connect the signal to the inverting terminal. The non-inverting terminal is connected to the ground. Okay, then these are the two resistors, R1 and RF. RF is a feedback. This is a feedback from positive to negative. Then there's a resistor in the input where R1 is connected. The V input is given. Okay, then we will measure the output from here. Okay, this is the thing. And the two things we should look at is voltage gain, how much the signal is amplified, that is given by minus RF by R1, and the output here is AV into the voltage gain into your input signal. Okay, this is the amplification. Okay, so how you get this equation? This is a thing. So that is based on the two golden rules of an op-amp, which applies when the two op-amp have a negative feedback. So one thing is the input terminals draw no current in an op-amp because the input impedance of the op-amp is very high, is ideally infinite. Therefore, there is no current draw in the input. Okay, both terminals. The voltage difference between the input terminals is 0. There is no, the voltage difference is 0. So actually, this will produce a term called virtual ground, because this is ground. This also, this voltage should be equal. This should be also should be equal. So the voltage here is 0. Voltage here is 0. Therefore, we can set these two currents are, because there is no current to here. The current should follow this path. Okay, which means that the current flowing through here, which is I1, should be equal to the IF. The current flowing to the feedback resistor IF. Okay, this is the basic equation. Then we should find the current. The current here is V input by R1. V input by R1. Then here is, because here the voltage here is 0 volt. Therefore, the first voltage is this minus this, that is V input by R1, and that should be equal to minus V out minus V out divided by RF, minus V out divided by RF. Okay, 0 minus V output divided by RF. Okay, this we can rearrange this equation. Therefore, we get the equation as minus RF by R1 into V input. Okay, that's why we get the equation. Okay, that's why we can actually change your resistors to get your desired amplifications using this circuit. Okay, so we'll try to implement this one in LTspice and see how the signal will be amplified. Okay, this is the circuits we use to do the inverting amplifier. That we need an op-amp, so you can select the op-amp from the components list. Okay, so you can search for OP07. Okay, OP07 will be, this is the op-amp you can use. Okay, this will be the have two inputs and one outputs. You have to give the power supply here. Okay, so this is the one where you have to give a resistor 1K and you have to give a sinusoidal signal to the input. Okay, so the signals values you can give like this. So you can give a sine. Then the DAC offset is 0, amplitude is 1. The frequency you can give us that any frequencies you can give. I give it's here 30. Okay. Okay. Then the output is connected from here, and the feedback resistor you can give us here. So R2 is given as a feedback. Then have to give the proper biasing for this one. So the proper biasing, you can choose a voltage supply here and give us 12 voltage, and it should be grounded. For the negative power supply also, you can connect here minus. You can give a minus 12 volt here, or you can rotate it to negative side. Then also you can give this here. Okay, this is a circuit, and you have to give the simulations as you can give a transient analysis for the stop time 0.2, start time 0, and the maximum time stamp I can give us a 0.01. Okay, then that's all. Then we can do the simulations. Okay, I can run the run button here. So if I run this one, I can check the input signal from here. So this is a signal of 1 volt that should be fed to here. Then I can check the output from here of the 6th pin. Okay, if I connect this one, this is the output. This is a blue colored signal. So first thing we can notice that it's a 180-degree out of phase. So here the maximum is coming here, where the actually it's a dip is coming here. That means it's a 180-degree phase out of phase. Then also you can see that this is 1 volt and it can be amplified to 5 times. Okay, if I change to one of these values, okay, to 10k, so let's say the component value is changed to 10k. Let's see what will happens. Okay, then we can run it. So this will be amplified to 10 times. So that's things you can change any value of this resistor. Combinations of RF and R1, you can amplify this signal to anything. So there is a clipping. Actually, you cannot go beyond to 12 volt. Maximum value for amplification is 12 because you are giving a power supply of 12 volt.